right, coming to you live from KubeCon here in Atlanta, Georgia. This is number 2025, and I'm here with James Harmison. How are you?
You're doing well by yourself.
I'm doing very well. So you're with Red Hat, and the topic that I wanted to ask you about, twofold, VLLM and LLMD. So start with that at a very high level. What are they?
Yeah, so AI models and Gen AI models in particular are just data. They're not programs that you can run on your own. So in order to run a language model, you need a program called a serving runtime. And so what VLLM is an open source enterprise grade serving runtime for generative AI models. It's got optimizations for a number of different accelerators, and the idea is that you can load your models onto those accelerators and perform inference against those models using either an OpenAI compatible, like a REST API endpoint, or if you wanted to write some Python code to interact with them in a sort of programmatic way, and that's also possible.
So just at a high level, first to orient us, we're talking inference, not talking training.
Correct.
And it allows you to interface, say, if you wanted to use Claude or if you wanted to use OpenAI, or is it smaller LLMs or SLMNs?
Yeah. So the question of the model is really a pretty complicated one. The idea is that you would take a client, like you would take Cursor, and instead of having Cursor point to Anthropic's Claude, you would configure it to point to your VLLM instance. The models that you can run vary, and it depends a lot on the hardware that you have available. But models everywhere from a couple of 100 million tokens can be productive, all the way up to 1 trillion tokens. Recently released was Kimi K2 Thinking, which is a thinking model that has 1 trillion overall tokens in a mixture of experts architecture. It takes a whole lot of GPU compute to run that kind of model. VLLM can serve all of those use cases. And the idea is that VLLM is really optimized around scale. So if you have lots of people with their clients connecting to one shared model, but running on your own infrastructure on your own terms.
So the V is for virtualization, I'm assuming?
Yeah, it's kind of like a vCPU, where a virtual CPU isn't really related to a CPU core. Well, VLLM is just an endpoint to access those LLMs, but it's sort of like a virtual way to manage them. And there's a lot you can do with like multi-host serving and things like that.
So how many of these would you have usually that you'd be using? And is that where LLMD comes in?
Yeah, even LLMD is a more complicated set of use cases. But the idea with VLLM is that you use it to serve whatever models you need to. And we see people doing everything from serving one really large instance of one really large model using VLLM, all the way up to hosting lots of smaller models. And doing this in, like, I see agentic architectures coming up a lot lately, where having little individual expert agents in one topic area work together in a workflow is really useful. So VLLM kind of gives you the flexibility to deploy in a way that makes sense. And then into that topic on LLMD, I mentioned like maybe lots of hosts or really large scale with lots of shared users. LLMD is an orchestrator that primarily is designed for VLLM, but it's not explicitly coupled to it. The idea is that LLMD helps you distribute your inference workload across lots of hosts, and it tries to do a few things really intelligently to make sure that you're getting the most performance you can out of the deployments that you've got and the hardware that you're throwing at the problem.
So where would MCPs fit in here?
Yeah, so MCP, Model Context Protocol. So an MCP server is an implementation of a program that has some domain knowledge in how to interact with some other service, and also is presenting this common endpoint. So when you build an agentic application, one of the things you need to do is you need to go get extra context to provide for your model. So if you're building an agentic architecture, you would have an MCP server for some domain-specific service that's useful for you. Your client would reach to that MCP server, gather context that's useful related to a user's query or a workflow or something like that, and then provide that context to the model at the inference endpoint that's hosted by VLLM or LLMD.
And so how would that fit in then with, can you double click on that, explain how it actually works? Not at a technical level, but so more broadly.
Broadly, yeah. So generative AI inference is stateless, which means that, you have a conversation with language models quite often, and you can ask it a follow-up question to a previous query, and it seems like it remembers everything that you were just talking about, but that model doesn't actually remember anything. The reason that it knows about the rest of your conversation history is because the client you're using sent the whole history to the model, and the model generates the next response in the context of the whole history. It doesn't have any state. It doesn't record the conversation that happened. So one of the things that's really useful here for these agentic architectures is providing them with extra information. So if I say like, hey, give me some information about sales order number 1032, and I have an MCP server that connects to my CRM and is able to go pull up sales order 1032, it can pull up a lot of relevant details. And when the query actually gets to the LLM, in the same way that my client before sent the whole history, now it can send, hey, oh, here's the details of order 1037 that the user was asking about. Now answer this question if all these facts were true. And that extra context is what makes agentic architecture so powerful, because we can keep the LLM on guardrails around like a topic that we have factual information for by augmenting that context, giving it the information with the question.
So VLLM, LLMD, how much of these are open source projects? Who's behind them? And what is there a commercial side of it as well?
Yeah, so like everything Red Hat does and participates in, upstream first, open source always. So that's the first top level, no holds barred. VLLM is a project that started out of Berkeley Skylab. So it was a research project originally, and its contributors are pretty varied these days. Everyone from NVIDIA employees to Microsoft and Amazon employees. Red Hat remains the #1 commercial contributor to the VLLM project overall. But it's an open source project where we're all sort of working together to solve these problems. Red Hat does have a commercial distribution of VLLM. We call it Red Hat AI Inference Server. And the idea is just long life cycle, support, training, et cetera, the normal Red Hat value proposition. LMD, also completely open source, was born out of a collaboration between IBM, Red Hat, and Google. And Red Hat is very actively involved in building llm-d, as is IBM and Google. And the open source project is taking off quite a lot, and LMD is one of the key standout features of our upcoming version 3 of our Red Hat AI platform.
Cool. And so, if just to end with, as we look forward to the next year, what would you see happening? How would you think these will develop going forward?
Yeah, one of the key things that LMD really enables is super high throughput interface. And so we're starting to see a lot of clients just beginning to tackle like centralized deployments of models with lots of internal users. And so lots of use cases around optimization are going to continue to make their way into the LMD project as people begin to bump into them when they're deploying these things at scale and bringing more and more use cases on. I think VLLM as the engine at the core of the default LMD deployment is going to continue to get low-level optimizations that make it, working with new types of accelerators, things like embedded accelerators from manufacturers like Qualcomm, or even more complicated things like the folks at Cerebras. And so LLMD is going to focus a lot on use cases and problems and optimizations. VLLM is going to focus on low-level hardware enablement and enabling a lot of new capabilities.
Cool. James, thank you so much.
Thank you. I appreciate the time.
My pleasure.